Hi everybody, today we will be talking about from Algebra 2 the properties of probability. So this is going to come after the section of learning how to deal with permutation and also combination. So this is going to be something that allows us to build off of what we learned previously, and we will see how that actually works out right now. So the first thing I need to go over are the three properties of probability which you have dealt with in the past, or at least you kind of maybe took them for granted, but that's pretty much it. The first one is that if you have the probability of something happening A and then another probability we call B happening, then that means that you need to take the two probability and multiply them together. So that's the first one. The P of A and then B is equal to the probability of event A multiplied by the probability of event B. Then the second one is that if you have the probability of, if you want to solve for the probability of A or B, meaning that you want either one of those two to happen, then you add the two answers together. So it's going to be P of A plus P of B. And the last one, this is something that is kind of new right here. P of A plus not P of A plus P not A is equal to 1. So meaning that the probability of something happening plus the probability of that same thing not happening is going to be equal to 1, because it's always going to be one or the other. So let's go ahead and look at some of these examples, so then that way you can see what I'm actually talking about. And also, for the case of P of A and then B, we have to note that A and B are events that are mutually exclusive. That is to say that they are not related to each other in any way whatsoever. So here's an example where we're going to get to use these three properties then. So the first one is the chances of carrots being served for lunch is 70%. The chances of that lettuce being served for dinner is going to be 65%. What is the probability of the following then? For part A, I want to find out what is the probability of serving carrots for lunch, but not for dinner. So that is telling me that there are two events that are happening. The first event is that I want to make sure that carrots are going to be served for lunch. So going by what we have right there, and let me just go ahead and write it in. So the probability of serving carrots, according to what we have, is supposed to be 70%. So that's 0.7. Now, what I have right here is I also need to make sure that lettuce is not served for dinner. And earlier, we were told that the probability of having lettuce is going to be equal to 65%. But what I don't want is lettuce. So that means that what I'm actually trying to use here is the probability of not having lettuce, which is then the negation of the 65%. So if it's 65% chance of getting lettuce, then that means there is a 35% chance of not getting lettuce. Because remember, the total has to be equal to 1. And so what I'm trying to solve for right here is I need to have both events happening. I need the probability of having carrots for lunch, and also, and then also the probability of not having lettuce for dinner. So I'm going to take those two numbers and multiply it together, and that's what I'm going to get then as an answer. So it's going to be 0.7 multiplied by 0.35 then. So we'll go ahead and put that in a calculator. So 0.7 multiplied by 0.35. So the answer is equal to 0.245, or you can say 24.5% chance of it happening. Okay. All right. Next part. This time around, I want the probability of serving carrots for lunch, or serving lettuce for dinner. Now, for something like part B, I think it might be nice for us to draw something called a Punnett Square, so then that way you can see all of the things that could possibly happen. So, in fact, we could have technically done it for part A, and that would have helped out too, but I figured that might be a little bit easier for you to see. So, let's go ahead and try to draw that out so you can see what I'm talking about. So here is what the Punnett Square is going to look like then, and here's what it's going to represent. Now, the top part, that is going to be for, let's go ahead and say carrots. Okay. Or actually, to be a little bit more specific, let's go ahead and erase that. And that way I can kind of specify a little bit more carefully. Okay. So the inside right here is going to be the probability of carrots, okay, for one of the box. And then the next one is going to be probability of not carrot. Okay, And let me just go ahead and maybe extend that box a little bit more. Okay, so kind of draw this out a little bit more, not carrots. Okay, and afterwards, we're going to also look at lettuce and do the same thing. So there's the probability of getting lettuce, and then not lettuce. Okay, so for each one of those, I am going to actually multiply them out to get what I am going to be looking for. So the first box where it says lettuce and carrots, that means that that's the probability of having both carrots and also lettuce. So if it's both carrots and also lettuce, then that means we're going to take those two and multiply together. So let's see, probability of getting lettuce, that is supposed to be 70% chance. And the probability of getting dinner, let's see, for probability of, sorry, getting carrots is supposed to be 70%, and the probability of lettuce is going to be 65% chance. So I'm going to take those two and multiply together. So here, let me just kind of like sneak that in on this side right here. This guy right here, that is supposed to be 0.7 multiplied by 0.65. So the answer right there, so 0.7 multiplied by 0.65, because I want to make sure that both happens, is going to be equal to 0.455 then. So about 45.5% chance. Now the next one over here, the next box to it, to the right of it, I am going to solve for the probability of having lettuce but not carrots. So then that means in terms of numerically, just like we had before, it's going to be 0.7 multiplied by probability of not getting carrots. That is going to be equal to, oops, sorry, I think I get those two mixed up. Let me just kind of backtrack a little bit if it's okay with you. Okay, let's see, the probability of getting lettuce, so that's going to be 0.65. So let me go ahead and put that in. Okay, 0.65 multiplied by the probability of not having carrots, so that's going to be 0.3. So 0.65 multiplied by 0.3, so that is going to be equal to 0.195. So that is saying that there's a 19.5% chance of it not happening. Now, if I'm looking at the probability of not having lettuce and not having carrots, both of these guys together, so I'm going to go ahead and take 0.3, which is the probability of not having carrots, multiplied by the probability of not having lettuce, which is 0.35. Multiply those two, so 0.3 multiplied by 0.35, that would give us 0.105, so 10.5% chance. Now, the last case, I'm looking for not having lettuce, but having carrots. So here, let me kind of sneak that over here on the side over here then. So probability of not having lettuce, that is going to be 0.35, multiplied by the probability of having carrots, that's going to be 0.7. So 0.35 multiplied by 0.7, and I think we just saw for that earlier, which is supposed to be equal to 0.245 then. Okay, so those are all the possible scenarios that could possibly play out in this case, because it has to be one of those four events. And note that the sum of every single one of those events should equal to 1, because again, those are all the possible things that could possibly happen. Now, going back to what I'm trying to solve for over here, I want to find out what is the probability of serving carrots for lunch or serving lettuce for dinner. So let's see then, which one of those actually falls into to the following category here. The ones that says I'm serving lettuce or I'm serving for carrots. So that means the first one right here, that can possibly work. And then in the other case, I am let's see, I am going to serve either, let's see, I am looking for lettuce, but not carrots. So that means that this one is going to be okay too. And then also looking at not lettuce and carrot, that one looks like it's okay too. So the only one that doesn't fall into the category of what I want is actually the last case where it says not lettuce and not carrot. So that means I'm going to go ahead and cross that out. So my answer for what I'm looking for is going to be 0.455 plus 0.195 plus 0.245, because all those three cases will allow me to have either carrots or lettuce for dinner, right? So long as I have one of those two, then I'm actually okay then. So adding them all together, then that means you're supposed to have 0.895 then as an answer, or you can say 89.5% chance. Okay, so this Punnett square is actually going to be pretty useful in this case here. Let's see. Part C. I think we can probably use that box that we just came up with to solve for this one. What I want to do now is find out what is the probability of serving neither vegetable. Well, if you're going to get neither vegetable, then that means it's basically the opposite of part B, what we're solving for. Basically, the situation what we crossed out, not getting lettuce nor not getting carrot, is going to be the case then. So the answer is going to be 0.105. Or one way of looking at it is that you can take the answer from part B, right? The probability of serving for either carrots or lettuce, and that would actually get us the same answer. So it comes out to be either, so they both come out to be the same thing. So that's 10.5% chance. Okay. And last one, you are serving for, let's see, you are serving at least one vegetable. And again, this is basically the same idea as part B, in fact. In fact, come think of it, if you look at it carefully, it's basically asking for exactly the same thing. So that means that you are going to just put the same answer for part B, because that is exactly the same question, except it's just worded a little bit differently. Okay. All right. Let's look at another case of this and see, hopefully, we can maybe use this Punnett square a little bit more. Okay. So here you have this guy, Thipofip, figured out that he has the following probability of passing each of his classes. So the probability of passing algebra is going to be 0.8. Probability of passing French is going to be 0.62, and the probability of passing PE is going to be 40%. I want to find out what are all the other possibilities. Now, before we actually do this problem, let's go ahead and solve for the other scenarios that are not written. So, for example, I want to find out what's the probability of not passing algebra. Okay, so I'll just go ahead and say P of not algebra. So that's going to be the opposite of 0.28, which is going to be 20%. So it's going to be 0.2 because it's 1 minus 0.8. In addition, I'm going to go ahead and look at the probability of not passing French. Okay, so if you are not going to pass French, then that looks like it's going to be 0.38 then, because again, 0.62 plus 0.38 has to equal to 1. And finally, for the last one, the probability of not passing PE is going to be opposite of 0.4, which is going to be equal to 0.6. So all 6 of these guys are definitely going to help us out here. The first part, now I want to find out what is the probability of passing algebra but failing the other 2. So if you pass algebra, then that means that one of them is going to be 0.8 then. So let's see. So to me, this is what it's saying. I want to take the probability of passing the algebra, okay, and then you're going to fill the other 2 events. So that means you're going to multiply that by the probability of not passing French, and multiply that by the probability of not passing PE. So you can see we actually have all of our answers there if we actually just solve for the negations of it each time. So the answer is going to be equal to 0.8 multiplied by 0.38 multiplied by 0.6 then. So let's go ahead and put that in the calculator. So let's see, 0.8 multiplied by 0.38 multiplied by 0.6. So the probability comes out to be 0.1824, or you can say 18.24% chance. Now, the second one says, I want to find out what's the probability of passing French, but failing the other 2. So this one is kind of the same idea here then. So what I'm going to do is I'm going to go ahead and take the probability of passing French, okay, multiply that by the probability of failing the other 2. So that means you're going to you're not going to pass algebra, multiplied by the probability of not passing PE. So same idea, take those numerical values and multiply them out. So that's going to be 0.62 multiplied by 0.2 and then multiply by 0.6. So take that and put in the calculator. So 0.62 multiplied by 0.2 multiplied by 0.6. So the answer comes out to be 0.0744. So you can go ahead and say that that's equal to 7.44% chance then. All right, now let's look at the other one then. The last case, well, basically it's going to be the last scenario in this case, right? The passing PE but failing the other two. So let's see, that's going to be passing PE multiplied by the not passing algebra and multiply by not passing French then. Okay, so let's go ahead and take those numbers and multiply those out then. So that's 0.4 multiplied by not algebra, that is going to be 0.2, and then not passing PE. Oh, sorry, you are passing PE, but you are not passing French, so that's going to be 0.8 then. So let's see. So that's 0.2 multiplied by 0.4 and multiply by 0.38. So that comes out to be 0.0304. So that tells me that you have a 3.04% chance of that happening. Okay, so those are not too bad. Now, part D says, I want to find out what is the probability of passing exactly one class. Well, if you read the problem carefully, it says you're passing one class. So technically, that means that you can have the answer in part A, right? Because that's passing algebra but failing the other two. Or you can have the probability of passing French but fail the other two. Or you can have the probability of passing PE but failing the other two. In essence, what I'm saying is you're just taking part A, part B, and part C and adding them all up. So then that means your answer is going to be part A plus part B plus part C, because all of those will consist of passing exactly one class. So your answer is 18.24% plus 7.44% and then plus 3.04%. And so let's see. Let's go ahead and add those up. So take that and add it with 0.0744 and then add it with the last one, which is going to be 0.1824. So it comes out to be approximately 28.72% then. Okay. All right. A lot of problems are actually kind of like this. The word problems where your, I guess like, next in the future part, like part D is going to be related to what you did in part A, part B, and part C. And that's what they call scaffolding. So it's actually pretty essential that you get those correct in order to get the next one correct. Let's see. So here in the last cases, I want to find out what's the probability of failing at least one class then. So let's see. There are actually quite a few of these scenarios, right? Because you're failing at least one class. You have to look at all of those cases, add them up, and then you also have to fail at least fail exactly 2 classes and fail at least exactly 3 classes. So here is what I'm saying then. Let's go ahead and write out all the scenarios here. Okay. So for me, if I say I want to go ahead and fail at least one class, right? Here, let me go ahead and write it out. So let's say the probability of failing nothing. Okay. And then we also have the probability of failing exactly 1. Okay. And then we also have probability of failing exactly 2. And finally, we have the probability of failing all 3. So those are the 4 different scenarios that you can actually have. Now, the one that I'm looking for is the probability that you fail at least one class. So to me, then that means that I am going to look at specifically this guy right here and looking at exactly this guy right here, and also looking at exactly this guy right here, because when I say at least one class, you can fall into any one of those 3 categories. And like I said, you can find each one of those and then add them all up, which I feel like there's going to be a lot of those scenarios. Or you can take the one scenario that is not considered and then subtract that from 1. Because remember, if you look back to what we did earlier with the Punnett Square, the total is supposed to be equal to 1. So why not just take what I am going to solve for easily and subtract that from 1? That's going to be a lot easier then. So this is going to be the same. My answer is going to be 1 minus the probability of failing nothing. Okay, so let's go ahead and write that out. So if you're going to fail nothing, then that means you pass all your classes. So that is going to be equal to the probability of algebra multiplied by the probability of French multiplied by the probability of passing PE. Okay, and take all of those and multiply it out. So 1 minus, and let's take a look once again. So it's going to be 0.8 multiplied by, for French, which is going to be 0.62, and multiply for PE, which is going to be 0.4. So whatever that comes out to be, let's go ahead and take a look. So 0.8 multiplied by 0.62, and then multiply by 0.4, and take that answer and subtract it from 1. So that is going to give you 0.8016, or you can say it's 80.116% chance then. Okay. All right, so that should probably do it. So hopefully this helps out. Yeah, if you like this video, give it a like, and